For the folks here in the class, feel free to ask questions. We can always cut that out of the recording itself, as well as any notes that we'll have. So hopefully we can record this and make it available for folks into the future. Can you guys hear in the back? The other question.
Can you turn it up a little?
Yeah.
Thank you.
Cool. All yours. Thank you.
Sure. So yeah, the agenda for today, I'll be talking about kind of how I got to where I am right now, my career journey, uh, my little brief perspective of informatics versus kind of more super technical like coding, programming, that type of thing. We're going to do a little case study example using some drug terminology. So I don't know that you get drug terminology much in school. I didn't, but it's something that once you're in a technical role where you're using databases with drugs and leveraging your expertise as pharmacists, it's good to have a little bit of background in how drug information is stored in a database, for instance. And then we'll do a live demo of using some drug information databases for drug terminology using a product that I'm working on actively called SageRx, which we'll talk about a little bit. That's what we're doing today. And yeah, if you have questions, this is very informal. Chime in, raise your hand, and if I don't see you, please somebody yell at me, and I will stop and we can talk, or there'll be time at the end also, I hope. All right, so my career journey, how did I get here? We'll go through this really quickly. This whole presentation is not about me, but I've always been kind of an inventor. Earlier, like maybe in like middle school, I discovered if you know what DOS is, it's the command line interface to Windows, basically. I discovered you could type the word QBasic into this thing on my computer and pulled up this application that lets you like write code and run it that can print words to the screen and make images and make drawings and lines and circles. And I was just fascinated. And so I was like, I didn't know I could do this and had the power to build stuff on a computer. Before that, I would tinker with like springs and suction cups and like stuff I found around my house or whatever. And now I could just use a computer to kind of play with and build stuff. In college, I was kind of torn weirdly between pharmacy and computer science because I liked computers. My dad's a pharmacist. Do I do this or that? Somebody kind of told me in high school, like, you can teach yourself computer stuff. You can't teach yourself to be a pharmacist and work in a pharmacy. So I went to school for pharmacy, but I've always been pulled back in that direction of the technical realm, as I'm sure some of you are if you're in this class. And so with pharmacy school, I didn't know that informatics, they didn't teach informatics at the school. There was one rotation that we had for informatics, and I was the only student in that class. And there was one elective. It was the only student that chose to do that elective. And there was like a professor, an assistant professor, and like a fellow teaching it. So it was like a 3-to-1 teacher to student ratio in that class, which was cool. I asked for one rotation for informatics and I was excited about it. But they gave me a drug information rotation. So I spent the month like looking up drug monographs and like answering drug questions, which is not what informatics is. So that was back in, I'm old now, but that was back in like, 2009 or 10 or whatever. So things are better now, I think. But I did ask, at one point somebody came, they weren't an informatics pharmacist, but they kind of came and to tell what they did. Somebody asked a question about creativity, like what can you do creatively in pharmacy? And they work, I think, in community pharmacy and retail. And they were like, I get to pick the color of the auxiliary labels that go on the prescription bottles or something. And coming from this like creative inventor background, I was very bummed about that. But I think informatics is a really creative field. Pharmacy can be creative too. But I was looking for something that let me kind of spread, flex those muscles. Straight out of pharmacy school, I went into community pharmacy for 5 years. It was good, it was bad, it was ugly. I'm sure you've heard people talk about community pharmacy. I loved it, but in times it was stressful, and I got burnt out after 5 years personally. And so I took a weird left turn into informatics. I didn't have my master's yet. I had only a portfolio of like a project or two that I was working on that was like on GitHub. So it was like a kind of software web development that I was playing with related to pharmacy, related to healthcare. I found a way to put a small portfolio of things that I would use during an interview process to show that I had like logical thinking skills. I knew technical stuff. I could apply it to an electronic health record, and ended up getting a job at Vanderbilt doing some work with their custom EHR that they had at the time, which was an e-prescribing application, and worked with a team of developers to like create features and fix bugs. That lasted like 3 months. And then they said, we're throwing away all of our custom stuff and we're going with Epic. And so then I got to do the full Big Bang Epic training, went to Madison, got certified. I put chicken and egg situation here because a lot of times, like getting into health informatics is hard because you kind of need a certification, but the only way to get a certification is to have a job, and the job requires certification. So how does that work? I got lucky, but I think there's other ways with residency to get in more easily today, and I'm sure you guys may be talking about that as well. Anyway, that's how I got my foot in the door. That was the custom EHR to Epic EHR. We supported Vanderbilt through a Big Bang Go Live in 2017, which is Big Bang Go Live. It means inpatient, outpatient, and like rev cycle. All of that stuff went live at once. Some people do like inpatient first and outpatient later and that type of thing. So the team that I was on, weirdly, was the non-medication orders team. So the Willow team's the pharmacy team for Epic organization. It was full of pharmacists. So I got on the non-med orders team, which is everything else. It's labs, imaging, nursing orders, diet orders, anything else that's ordered in the hospital. But was able to kind of keep the pulse on certain medication-related things like MedRec, like respiratory therapy, which used bronchodilators, and we had workflows built for them and decision support for them with bronchodilators. Like anything I could do to get involved with the pharmacy space, I did. But it wasn't, not a pharmacy first role. Weirdly enough, my manager was also a pharmacist on that team. So Vanderbilt has lots of pharmacists working in health IT. They are kind of unique in that way, I think. But anyway, that's where I am now. I'm now like a lead analyst, so I work with all of the inpatient teams, not just the non-medication orders team. I work with like our Peri-App team, our ED team, the Beacon team, which is chemo and oncology, ClinDoc, which is nursing. So I kind of work across all those teams and support bigger projects. I'm kind of in a different role, still not necessarily in the pharmacy domain, although I know all of the pharmacy people that work in health IT as well. So hopefully that wasn't too long, but that's my background. And I just want to show you that it's non-traditional. I may have gotten lucky. Luck is a component here for sure to get in when I did and just get my foot in the door. But I have a weird path. I know other people that have taken weird paths to get into technical positions and roles, and just wanted to share all I got here. So what I do in my day job is informatics. Really, it's not pharmacy informatics, but it's informatics. I have an oversimplified example or analogy of like informatics versus coding. So informatics to me is like building cool things with Lego bricks, right? Like Epic is a vendor. They have a software product, which is an electronic health record. They give you a bunch of cool Lego bricks to build stuff with. You decide sometimes like how they go together, whether to use this type of brick versus that. But at the end of the day, it's kind of like you get bricks from a vendor and you have to know this very complex system. You have to know how they work together. You have to know all of the configuration options, like how you can possibly configure stuff, which is a lot of stuff to know. You have to know how people will like use the thing that you built. You can't just put something out there and expect that people will use it the way that you think they will use it, because they won't. Standardization and maintenance is a big consideration for anything you do in informatics, because you don't want to have to like maintain the same thing in 17 different places. You'd like to rather have one source of truth for stuff, and then if that ever like needs to be changed or breaks, it's just one place to look for it and not 17. And then logical thinking, which I think pharmacists are really great at in general, of just being able to think logically about stuff. Other people are too, but I mean, I just, coming from pharmacy, like pharmacists are really good at that, and that's a huge part of this. Being good with informatics is just thinking logically and thinking through problems, and maybe creative thinking as well. So that's informatics. Coding, if we're using the Lego brick analogy, is kind of like making your own Lego bricks and then building something with them, like having kind of like a wider range of freedom of like what you can do, because at the end of the day, if you can't do something with Epic, it's on Epic to do some research and development and like release a feature or do something. Like if you hit a wall, you can't go much further past that wall without Epic developing something and releasing a feature that you need or whatever. So coding, equivalent of like where I've come from, like Vanderbilt went from a totally custom electronic health record where they could do whatever they wanted, and it's kind of like a blue sky scenario. Um, but if you're just starting on your own, it's kind of like you get to pick your language you want to program with. You guys are learning some Python, which is a great language to learn. There's also JavaScript and other languages that are popular for front end and back end stuff. But it's like you kind of pick which language you want to try to work with. Front end versus back end. Front end is what users see and interact with. Back end is the database and like APIs and how things actually work in an application. If you're in the health IT space, there's lots of standards, and integration is a huge thing. If you build a really cool app, but it doesn't work with an EHR or like anything, then nobody's going to use it, kind of is the moral of the story. So integration is a big piece of it. If you're doing some custom stuff, you got to support it. If it breaks, it's on you to fix it. And then, like I said, the double-edged sword to being a blue sky, like sky's the limit thing, is that you got to say no to people. Like, and like when I worked for the custom development e-prescribing stuff for a while, it's kind of like, can we do this? Yes, we can do anything, but should we? And what is the expense and what's the cost? And do you really want that? It's going to take 6 months to do that, and we could do these things instead. So lots of like that type of thing also applies in informatics, where your resources are limited, but even more so when you're not limited at all by a vendor or anything, and you can kind of do whatever you want. You got to decide what to prioritize, how to scope things out, and that type of thing. So anyway, I don't, in my day job, I don't do lots of coding, but I felt from a background of coming from like working on QBasic, and we're doing some development on my own on the side and going into informatics. The coding stuff on the right is what I kind of don't get. Even if I was in pharmacy informatics, I don't get that at working in informatics. And I personally like that stuff. For a lot of people, informatics is awesome, and that's all that they need. And that's whatever. They don't want to go into do the coding stuff. Fine. For me, the coding is different from informatics. I just want to make that point that, you can be technical, and there's different flavors of being technical. And so anyway, for me, I define my niche. And so I was kind of still craving the healthcare, but coding. I started this organization called CodeRx, which is our little motto is like pharmacists who code and developers who healthcare. And so, like I said, I love informatics, but I needed to scratch that itch for coding and like more super technical stuff in my free time. And I was like, who else out there is like me? And so in 2020, when everything was shutting down, I started a Slack community and called it CodeRx, and people started joining. I don't even remember how. I think I was scalping people from other Slack groups for pharmacists and being like, hey, you mentioned this buzzword about, like, you said Python, so hey, do you want to come into my Slack and whatever? And if you guys don't know what Slack is, it's just like Discord, or it's an online community that you can kind of curate and be the moderator for. That's all it is. But anyway, 2021, 6 people in the group came together and we competed in this competition. ONC, the Office of National Coordinator of Health IT, sponsored a competition for synthetic health data, trying to make it better, more realistic. And we ended up coming in first place for this competition after being around for only a year, and everybody having full-time jobs and just chipping in for no money in our free time. So I was really proud of that. You can find, we can get more. That's not today, but you can read about that if you're curious what we did. We probably had like 100 people, 200 people in the Slack group at that time. And I was talking to a buddy of mine. I was like, yeah, the Slack where pharmacists who code, got 200 people. He's like, wow, you found them all. You got all the pharmacists who code in your Slack group. But today there's 1,000 of us, which is more, but still not a groundbreaking number. But anyway, 2022, I realized from that project that it was hard to work with the data that we needed for that project. And I started working on this thing called SagerX, which we're going to talk about later. So SagerX kind of came out of the pain I felt from like having to use drug data from the raw sources for this project that we ended up winning with. And I thought that it would be great to have like a better just starting point if you were to build an application to have the data related to medications that you needed more easily, kind of like as like off the shelf. So started working like the next year. Been developing it for the last couple of years. 2023 did a little bit of expansion, and this year I decided to open source the whole project. But it's open source. You can see everything that we have done with it so far. If after this presentation you feel motivated to look into it and use it, you can. If you want to contribute to it, you can. So it is open source, and now we've got 1,000 people in our Slack, and yeah, we're still growing and just kind of actively working on stuff and chatting about very nerdy pharmacy tech stuff. If that's your jam. This is kind of a graphic that I use to explain the type of niche that we are. So when I say API, what does that mean to you guys?
Guesses for the group. Before I make Nathan answer, who wants to say them? What's your guess, Nathan?
Was the P an API for like protocol? Was it?
Sure, you can speak up. You gotta hit the mic.
Is it muted?
No, it's on.
Oh, okay. Does the P in API stand for protocol? Is it?
Oh, sorry, I thought you were asking Robbie. No, nope.
He was, but I want to defer to your decision and how you want.
All right. We'll move ahead. So in pharmacy, API is active pharmaceutical ingredient generally, and that might be more of an industry pharma term or whatever, more so than pharmacy school stuff. But in the technical realm, most people that are from a programming or software development background will hear that and be, oh, that's an application programming interface. That's the thing that you may have talked about, may or not have talked about it all yet, but software, you generally, if you have like an application that integrates with Facebook or something, you can use Facebook's API to like request your list of friends or something if you've already authenticated with an application. And so you ask Facebook's API query or a request, they send back a response with your list of friends or whatever. Like that's usually how different programs and software integrate with each other. But people that are coderecs that have kind of been in the pharmacy industry for a while and are technically savvy, it means both of those things to us. So it's kind of like interchangeable, and you usually have to clarify which one you're talking about. So anyway, let's go into a case study about drug terminology. I don't think, have Ravi, correct me if I'm wrong, but drug terminology isn't like a big topic even in informatics still, right? Like we're not having a huge background in it.
Yeah, so in regards to terminology, folks have at least watched a little bit of the working with meta information video the series and playlist that you created, but in terms of our actual curriculum, not really in our core curriculum and only barely touched on in regards to this class as well.
Okay. So this is going to be very high level, just kind of an introduction to what is drug terminology and maybe a couple examples of why it's important and useful and why it might be important in your future careers. And I just want to clarify that it is not unusual to not have this as part of your curriculum. I even talked to my manager for my old role, who's now the director of the Willow team at Vanderbilt. And, he never ever learned how to work with drug terminology in school in informatics. And it's something that most people just kind of learn on the job, weirdly enough, even pharmacists in the informatics realm. So dabbling in it at all at this point in the game is, I think, going to pay dividends if you're familiar with the concepts, and then can apply it to other stuff as you kind of go into your careers. And this is my favorite data quote: "Without data, you're just another person with an opinion." So this isn't the type of data that's like proving a point necessarily. This is more of data that's like describing medications. So it's kind of it's not like patient data or like clinical data that you can see trends and like prove out stuff. It's more like data about drugs. Like, what is a drug? What are the things that make up a drug? It's like a data model for medications that we're kind of talking about today. Like ingredients, dose forms, that type of thing. SagerX, like I mentioned, is this project that started in like 2022, and what it is open drug data pipelines that are curated by pharmacists. Data pipelines are a term that you may not have heard of, but in the data world, like people who work with data, just kind of a way of like getting data from one place to another, and also maybe transforming it or making it more useful for end users that need to work with it. I pipelines is what everybody calls it, but for some reason I think of it as a plant, which I garden a lot. It's kind of my hobby. So when I was making SageRx, I was really starting to do a lot more in my backyard, just gardening stuff. And so I think of it as like a plant. So like the roots are pulling raw material out of the soil, which is coming from government organizations, typically in this case, like Medicare, Medicaid, Centers for Medicare, Medicaid Services, FDA, Food and Drug Administration, NLM is the National Library of Medicine. All these people, all these organizations put out really valuable drug data information, like drug information. But as we'll talk about in a little bit, it's very raw, and people that work with it sometimes struggle. And it takes that and it transforms it into like the leaves or whatever of the plant, which are like normalizing it into a way, so the two different sources that might have things in different formats are the same, using public standards and open standards for stuff, as opposed to proprietary coding systems that you have to like license or pay things for. Custom views, which is just a way of saying that we are not just getting the data into one place, but we're transforming it in a way that otherwise would take a lot of work or be really hard. Unified API, there's that API again. So the eventual goal is to maybe make a thing that if you're making an application, you can like query SageRx and get a response back instead of having to query 7 different disparate sources of data that might be provided. And then automatic updates. So these data sources, some of them update daily, some update weekly, some monthly, some quarterly, some yearly. So they're always being updated at different times of the year. And so this also will keep the data in sync with the updates coming from the organization. So this is like the equivalent of the back of the napkin drawing that like people starting in inventions or like startups do. This is like my back of the napkin drawing where I was like just kind of ideating on what this could be. But it's kind of it still holds true with what I'm working on for this today. All right, here come the memes. So open drug data is valuable. This is the first point of like why I started doing this. This is, a lot of people that are starting up a health tech startup, their options are kind of like put a ton of money into a commercial drug database, tens of thousands of dollars sometimes per year for licensing these databases, which for people like a big healthcare organization, you have to do that, right? But if somebody is starting up, like I got a cool idea, I want to prove this out and make a proof of concept. I need data to do this. Sometimes they can afford it. So the opposite of that is learning something like RxNorm, which we'll talk about in a little bit. In its raw form, it takes a lot of reading documentation and like knowing how it was put together, and also clinical knowledge of pharmacy and drugs and stuff to like even begin to use it. So it's like the opposite end of the spectrum where it's like really, really, really kind of hard to get started with it, but it's free. So there's that. So there are kind of two extremes for somebody that wants to get started like building something in this world. But aside from use RxNorm as a specific example, there's other sources of drug data. So Food and Drug Administration, or FDA, has a really important source of data called the NDC directory. So I'm sure you know what NDCs are or have heard of an NDC. If not, National Drug Code is if you've ever dispensed a prescription in a pharmacy, NDC is on the box or on the bottle. It's the manufacturer, the product, and the package size in a 3-segment code. And FDA maintains this list of like all of the FDA approved NDCs and like what approval process or pathway they went through, information about those NDCs, like the ingredients and the strengths and all that stuff. So FDA is one really great source of information. NLM has RxNorm. RxNorm is basically a drug terminology or an ontology, which is it's like the standard for interoperability between organizations that are sharing medication data, because it's open and maintained by the government. But at the same time, like a lot of I don't think many organizations use RxNorm in its like raw form. They'll usually use one of these commercial drug databases and then map that to ARCSnorm to be able to be shared with another organization who might use a different commercial drug database, for example. But ARCSnorm is super important, and the principles you can learn with it are very similar to the same principles that you'd be learning if you go to a healthcare organization that uses a commercial drug database. So we're going to focus on ARCSnorm today with the examples that I have. NLM also puts out a service called RxClass. So that's a really great way if you wanted to not just know about a specific medication, but like what are all the HMG-CoA reductase inhibitors that are out there? Like that you can run a class for that, and it'll show you the drugs that are part of that class, for instance. Or you could say like, what are some drugs that may treat Parkinson's or something like that, and it'll show you drugs that may treat Parkinson's. So there's different classifications that if you're trying to group drugs together and see what drugs are part of the class, that's really useful. Medicare, Medicaid. I'm sorry, the question? No. Medicare, Medicaid puts out NADAC, which, if you've not heard of NADAC, it is the National Average Drug Acquisition Cost. It's a drug pricing data source. So retail pharmacies voluntarily report the invoice prices that they pay for medications at an NDC level. And this consulting firm aggregates all of that data and gives it to Medicaid. So Medicaid knows kind of the average amount of money that retail pharmacy pays for a drug, so that they have some sort of a baseline for drug pricing. And this stuff is all publicly available if you can get it and know how to work with it. And then Medicare, Medicaid has tons of data about just like formulary for Part D and like eligibility information, or just a lot of data that's out there. All over the place. That's really useful for specific use cases for people that are like in the industry. So that's just a subset of some examples of where drug data is and like why it's important and possibly valuable, especially if the alternative is paying tons of money for something that you might not need the full thing for. But open drug data is hard to work with. So there are different file formats all over the place, from just like CSV to Excel to like RRF to like tab delimited things to like columns with rigid like character spacing. There's just, if you want to work with like two different data sources, you might have to work with them two completely different ways to get them into a shape that you can actually combine them and start to work with them. And so on top of that, like a lot of times there will be like several layers of zipped files like together, where you have to, like, if you were doing it manually, to sit there and like unzip 7,000 files to get down to the base files and then work with those base. So just like lots of tedious stuff that you need to do. If either you automate it or if you do it manually, you still have to like figure out how to do it. Mentioned this before too, but these are all updated at different times inconsistently. So generally, like as an example, one data source is generally updated every Wednesday, but sometimes it's posted on Tuesdays and it's posted on Thursday because it's like somebody doing it and pre-processing and putting it up there. So it's like not every source is as bad as that, but like it's not like you can guarantee that this number of the month is going to be out there. So if you're trying to get the freshest, like most up-to-date data, you're either going to miss it, or if you're automating it, or you're going to like be a few days late, or I don't know. So it's just the timing of all these updates are hard to keep track of, for one thing. And then post-processing is needed from many sources. So if you get an update monthly, but every time you get an update, you got to like do these 7 things to process the data in order for you to use it. Like, I don't need these columns. I need to change the format of this column to be a date. I need to, blah, blah, blah. So all the stuff that you normally have to do if you work with this data, a lot of times, every time you get an update, you have to redo that stuff. And people generally that don't know how to use like technology to do this, part of their job will probably be just a series of steps where they like download a file, do that stuff manually, step by step, and you look at them and you're like, this is how you spend your time in the day. And if you know better and know how to automate stuff with Python, for instance. And so that's kind of one thing that SageRx does too, is like some of this post-processing that's needed for these files to be really useful. I'm going to stop here before I go further to see if there's any questions.
And I'll take a second to pause too, because I'll also share
live demo and just. I want to go through this kind of quickly to get to the live demo, because I think that's going to be valuable to show this as a real example. But this is what the automated extraction and loading part of this looks like. So all the pain points that I mentioned before, if you can solve them once and then automate them, they don't become, as problematic anymore. And that's kind of what we do with this tool called Airflow, which is an open source application put out there by Apache. It's a kind of a task scheduler, so we can schedule the time that things are updated. So if we know that every month this source updates, we can schedule it to like try to get that downloaded monthly. If it's weekly or daily, we can set those times. Some sources go back to like 2013 and like they have, monthly updates every month that are archived. And if you want a full picture of data back to 2013, you'd have to kind of sit there and like download every month, 12 times whatever number of years. But we can automate that with this and say, get this month's and also every month back to 2013. And with a button, it just kind of runs through and churns through and fills up your database with all that data. And then what kind of goes without saying, but after it, what it does is extracts, meaning downloads those files or whatever, and then maybe processes them, like unzips them all and gets the raw data at the base level. And then the loading part is it loads it into a database. So you're not just working with files, you're actually working with a database that you can query with SQL. So an example of this, you turn on one of these, they're called DAGs. I don't know if you get into what that means, but they're called DAGs. You turn on FDA, NDC, if you want the NDC directory. It runs through 4 tasks. So the first one is extract, which means download from FDA. It comes as a zip file with two CSV files inside of it. One CSV file is called product.csv. The other one's called like package.csv. So it extracts the zip file, unzips it, and then it loads the product CSV into a database, and it loads the package CSV into a database. CSV is just comma separated value. If you don't know what that is, just like a spreadsheet, basically. The last step is transform, which we'll talk about in the next slide. And another thing to point out is these tasks don't happen sequentially. They can happen in parallel too, because we can extract it, and then we don't care if package is loaded before product. We run them both at the same time, and whichever one finishes first, they have to both finish, and then we transform. So there's kind of complex stuff you can do with these tasks. Transformation is the part where we're making these custom views or making this data more useful than it is just out of like raw from the data source. So this is all done in the SQL. So it's nothing fancier than just writing a SQL script, but it's automated, and there's lots of other cool stuff that happens because of the tool we're using, which is called DBT, or Data Build Tool. So we can write SQL queries, or we call them models, to transform data into different useful tables. And I'll give some examples. So the NDC directory, like we keep referring to, in the raw data, one of the cells of for each row, which each row is like a product, like a lisinopril 10 milligram tablet or something. There's a cell or a column that has all of the classes that product is part of. Like I mentioned before, ARCS class, like classifications for that product, but they're crammed into one cell separated by semicolons. One model we have splits those out into 3 different rows, and I have an image to show what I'm talking about here, but it makes it easier to query. ARCS norm, huge transformation happens here because I mentioned before it's hard to work with raw ARCS norm data. If you watch the working with medication data, I kind of go into that. I'm not going to go into it here. And NADAC, we add some columns that are useful because NADAC by itself doesn't tell you the difference between one month and another, or like how much a price went up or what percent it went up versus the last month. It just shows you the numbers, like the prices month to month. So we added a column or 2 columns that were like the price change and the percent change from the last month to make it easier to work with the data if that's what you're working on. So all this stuff is automated. When we press the button, it just kind of does all this stuff and updates the tables. This is an example of what a raw row will look like for one medication product. So this is what I'm talking about, these farm classes. They're separated by, I think, commas actually. So you can see there's one here for EPC, one for CS, one for GLP-1. I don't know if you can see it, but there's 3 different classes for this product, which is Trulicity, jammed into one cell. One thing we do with this transformation model is, if you look down here now, each of those three classes is split into its own row. So this table, the granularity of this table is one row per class per drug product. So it's useful because if you ever wanted to find all the drug products that were GLP-1 receptor agonists, you could use this table to not just get this one Trulicity, but get all the other products that were GLP-1 receptor agonists, because it would be really hard to do that using this all crammed together into one cell. You have to do like string matching, which might be inconsistent or something like that. So by splitting it into its own row, using a SQL script or data model, we make it a lot easier to work with it for that reason. And it automates it. So every time we get a new file, this automatically updates. That's just one example. All right, we got 20 minutes left, which I think is enough time to go into a demo. So I'm going to we're going to do hopefully two things if we have time. We're going to start with an example of like a patient med list and how it might be stored in an EHR, and things that we might do with the med list from a informatics standpoint using drug terminology. So this is a patient's med list. In the EHR, each of these medication products might have an identifier. So Epic uses records called ERXs, which represent medications in Epic, but each of those ERXs probably have an identifier from FDB or like a drug information database, like a commercial database that has their own identifier. In this case, we're using ARC's norm identifiers. So we're not using FDB or Metaspan or any of the other commercial drug databases. But as you can see, like they're all different medication products that are on this patient's chart. Using ARC's norm 2, ARC's norm normalizes the medication names themselves. A lot of this looks very similar, but you can see in some cases, like, I don't know, here it alphabetizes like H and L as opposed to how we might normally think about it as like losartan hydrochlorothiazide. It even goes further and like sorts things in alphabetical order. It normalizes strengths down to like the milliliter. So it has like a very normalized drug name because everybody calls drugs different things in different systems. Your EHR might have a name for these products that are slightly different from another EHR, but ARC's norm has the same name for both those products if you can link them to an identifier. So these identifiers are at the product level, meaning it's something that you can dispense. It's an actual product you can hold in your hand, and it's like, you can take it. So it's the ingredient, the strength, and the dose form. So atorvastatin, ingredient, 40 milligram strength, tablet, dose form. It has to have those three characteristics to be like a product identifier. It could have multiple ingredients, like losartan hydrochlorothiazide, multiple ingredients, but they're still ingredients. And then they have strengths and they have a dose form. So if you watch the work with medication data video, you saw we talked about how ARC's norm has identifiers for products, but it also has identifiers for ingredients. It has identifiers for dose forms. It has identifiers for strengths. So this is a product level identifier. So the first example I have of using this data is there any duplicate therapy in this med list? And you might look at this and see it immediately. And it's not that clinically exciting what the duplicate therapy is either. I should have picked a better example, but like from a system perspective, these IDs are not different. So the spoiler alert, this is what I'm going after. We've got hydrochlorothiazide here and hydrochlorothiazide here. The product IDs are different because the products themselves are different. One's a combination product. There's different strengths. So you can't just compare the products and say, oh, this is duplicate therapy. So how do we determine programmatically, how does a machine know that this is the same thing? Obviously, you could kind of compare the words, but that's just not good enough clinically, right? We can't just expect it to parse through words. Now there's LLMs that might do that and figure it out, right? Like ChatGPT, et cetera. But from a data perspective, we're going to walk through an example for how we actually do this. So this is the live demo. Any thoughts before I jump into this, or while I prep for this? I will get it quick queued up.
You're doing too well.
All right, good.
Perfectly.
sure that's what it is. I'm sure that's what it is. Yeah. All right. So each of these identifiers here is the same as the ones that you were just looking at, right? And the other screen. So it was those RX QEs for the product identifiers. I'm just doing it this way because I'm lazy and I didn't put that med list into an actual database table or anything. So we're limiting our scope to just these products as if we're looking at this patient's med list. What I'm doing here is this is a view of the database that gets produced by SageRx as a result of the stuff we talked about before, extraction, loading, transformation. So RxNorm, like I mentioned in the working with medication data videos, goes under some heavy transformation into a bunch of staging tables and intermediate tables. And so like all of these tables here from RxNorm represent different things like ingredients and dose forms and NDCs and clinical products. And then there's intermediate tables that take you from things like clinical products to dose forms or clinical products to ingredients and things like that as like a kind of a shortcut from point A to point B. So what we're starting off with here is just a simple select all from our staging table, SageRx, staging RxNorm clinical products, where the RxQE, which is the identifier of the medication, is in this list of things that matches the patient's med list. So if we run this, we will get basically that patient's med list with the RxNorm normalized names and the list of RxQEs. Not too exciting, but it's a starting point. So again, none of these IDs are different, just like we showed before. So the next step we're going to do is use a intermediate table. This was a staging table. It is just a list of products themselves. What we're going to do next is go from clinical products to ingredients. So the same list of product RxQEs. We're going to use a staging table where we're left joining in this staging table that will take you from those product level RxQEs to whatever the ingredient is within that product. So if we run this, we get an error because I messed something up. There we go. We run this, we get that same list of meds, but now we have columns for the ingredient that's in each of those products. So this glipizide, metformin, glipizide/metformin, hydrochlorothiazide, losartan, hydrochlorothiazide, losartan, down the row. These two still are different though. So if we look at this one, it's the term type is MIN in RxNorm, which is multiple ingredient, and this one's a single ingredient because it just has hydrochlorothiazide. So you can see even at the ingredient level for a product, they're still different. Like we still can't use this level of information to get down to whether or not there is a duplicate ingredient or duplicate therapy for this patient. So RxNorm goes one level deeper, where we can get to the ingredient, what I call or refer to as the ingredient components. So it's like what are the individual ingredients that make up those multiple ingredient products, right? So starting with the same list of drugs, all I do is I change the intermediate table here. So instead of going from clinical product to ingredient, we're going to ingredient components. So it takes the granularity down to the very lowest level for ingredients. And then I just selected some specific columns here to make it easier to see what the result is. So if we look here, we're going to see that our glipizide metformin product and our hydrochlorothiazide losartan product is split now into two rows. So these rows are actually duplicated, whereas every other row is just one row for product. So the glipizide metformin maps to both glipizide and metformin. Hydrochlorothiazide losartan maps to losartan and hydrochlorothiazide. So we now have 9 rows, even though there are only like 7 drugs on this patient's med list, because each row represents like the very base ingredient that's in that drug product. And over here, if we see the identifiers of the base ingredients, we can see, oh, we got 2 of 5487, which represents hydrochlorothiazide. So if you program a computer to look for this, it can easily detect these numbers are the same. This patient's med list has 2 of the same drug on it, and prompt a user to like say, is that okay? Is it not okay? And all that type of decision support that you might normally see. So that's just an example of how drug terminology and the coding of drugs can be used for like a duplicate therapy alert in a system by going to different levels of drug terminology for a product. Questions about that?
I've got one actually. Question for you about the RxQE numbers. So I can see why the ingredient component RxQE might be different, but what's the real difference between just RxQE and the ingredient RxQE? Why are those numbers different?
So do you mean like the product RxQE and the ingredient RxQE?
Yes.
Okay. So like going back to the query we did before, I'll just pull it up so we can show what that looks like. Like I think I got rid of the product RxQE in this one. So we've got like these are the clinical product RxQEs that represent each of these things. And then like, for example, atorvastatin 617311 is different from the ingredient atorvastatin of 83367, right? Is that your question? Like, why are those 2 different?
Right.
So, like I mentioned before, this ID represents not just the ingredient of atorvastatin. This ID represents ingredient, strength, and dose form. So, even within atorvastatin oral tablets, you're going to have a different product RxQE if it's a different strength of atorvastatin.
Okay.
If any of those 3 things change, you get a different product RxQE.
Great. Thank you.
But all 3 of those are, anything in the atorvastatin, regardless of strength, is going to have the same ingredient RxQE, right?
Got it. Thank you.
Good question. All right. Any other questions? I'm going to go one more example with this med list, and then we'll do something different if we have time. All right. And another use case could be one thing that we're kind of working on right now at Vanderbilt is stuff around making sure patients that are on an NPO diet or a nothing by mouth diet don't get oral medication. If it's including medications, like I shouldn't have anything including meds, making sure they don't actually get an oral medication. And so one thing that's useful to know from a EHR system is which of these meds that are active on a patient's chart are oral meds versus like injectable versus inhaled versus all that other stuff, any other kind of dose form or route. And so with the same thing that we've just been doing, all I did again is we can swap a intermediate table here to go from clinical product to dose form. And then we can take our list of clinical products. If we run this, it's not terribly exciting because they're all oral tablets. I should have, again, done a better example, but you can imagine this could be a list of like oral tablets, injectable, solution, inhaled medication, nebulized medication, whatever. And then the system could know that, oh, if any of these have oral tablet or oral capsule, that and the patient's NPO, we should probably alert somebody at some point, right? So knowing things about products more than just ingredients is also useful, like dose forms and things like that can be important for different workflows and decision support in the system. The other thing I wanted to point out is you guys are learning about APIs. Well, yeah, let me show this really quick. This is all very quick and easy and simple, but the stuff behind it is complicated. So this is the clinical product, the dose form thing we just looked at. This is the SQL that powers that table that we just queried as like select all from intermediate clinical product dose form. It's this SQL, but it also depends on these models, which if you go to each of these models, they can be really, really long. So there's lots of SQL work to develop these models to make it really, really simple for the end user to then write a query like this that we're looking at. But that's kind of the purpose of SageRx to abstract away the complexities and make it really easy to work with this drug data. The other thing I want to call out is that for things that we're doing here, there are APIs available from RxNorm directly that you could write a program instead of using SageRx and like the raw data and download it and like the custom views that I'm making. You could just query RxNorm. It's up to date. It's queryable, and it works. And so, here's an example of a query for I think the atorvastatin. So I use the RxQE for atorvastatin up here, queried the API from RxNorm, and you can see all of the things it returns. One of them is ingredient. So this is like the ingredient that makes up that product, and all the other things about it are listed here too. If you see here, it doesn't have anything for multiple ingredient because it's not a multiple ingredient product. But if we query a multiple ingredient product, which is, I think this was glipizide metformin, you can see, oops, that we have ingredient section here, IN, which has glipizide and metformin, and it also has an MIN section here, which is glipizide metformin. So you can theoretically build an application that uses the response from this API. I requested information about these RxQEs, and it returned information from the API about them. You can certainly use this to power some sort of an application instead of using this database thing that I'm talking about with SageRx. So I just want to point that out since you're learning about APIs and you can play with it. But where this kind of breaks down is if we're working with like a huge spreadsheet of data, which a lot of times I am or people are, instead of like making an application, they're doing some analysis with like a big spreadsheet or a big database. And so I'm going to kind of show you what that looks like. So let's switch over to a spreadsheet view. If you were to use an API for something like this, you not only have to write like a custom Python script to like ingest the spreadsheet, hit the API 2,700 times to get a response and then process that response. Just a lot of work for something that you could do a different way. Let's imagine this spreadsheet represents like NDCs that are dispensed at a pharmacy over the course of like 90 days or something. It's not really, but you can see a list of NDCs. However, the source system had those NDCs represented as product names and then like the number dispensed, right? So if we were asked to take this list of NDCs and say like, what is our most commonly dispensed product in the last 90 days in the pharmacy? You'd have to know that like, even though these two things look different, right? The product name is different, the NDC is different. They're probably the same thing. It's got the same strengths. I don't know if this is a 45-gram one, but it doesn't really matter because this is probably the same product. Might be different pack size or something. But it would be a lot of tedious effort to go through this, like, okay, these look the same, this, whatever. So we can make this a lot faster by, if this was in a database, just doing a join to the RxNorm data that we were working with before. If it's not in a database, what you can do is download one of these tables as a spreadsheet. So this is the intermediate NDCs to product table. Download it as a spreadsheet that has like 240,000 rows. And we can have a column for NDC11, a column for RxQE, and a column for product name. And then if you know how to do VLOOKUP in a spreadsheet, or if this was in a database, we could do a simple join. We could join that SageRx NDC to product spreadsheet to this spreadsheet based on the NDC. So now if you look at these first two as an example, these are the same exact normalized name for these two products. So you know that those are the same product. Again, here, same normalized name for these two products, even though they look different and have different NDCs. So once we have this column pulled in, which is all the normalized names are highlighted red if they're duplicate names, meaning that we basically do have two of the same product, different NDCs. We can make a pivot table with Excel, and we can see, I just made it hard to see, crap, sorry. I'm running out of time. Anyway, with our pivot table, I'm going to make this column smaller. Then our most commonly dispensed product, if we do a sum of all of the normalized column name, is this fluticasone nasal spray. The second one is lidocaine. And then you can see that like this lidocaine was the second most commonly dispensed product, but there were 6 different NDCs that were dispensed that were all the same products. That's kind of information that might be useful to somebody. So leveraging this normalized data from RxNorm in this format that makes it easy to work with can help you do spreadsheet analysis too, if you know how to use it. So I think that's the end of the demo, and I never get this right, but let me swap this and say thank you. And this is my CodeRx email. And if you go to coderx.io, you're more than welcome to join our Slack community. Click this button. We got a newsletter. Sometimes I write stuff. Sometimes Robbie writes stuff, actually. And then stuff about SageRx is in this SageRx page with lots of information. So I will, if you guys have any other questions, I know we've given you time to ask other ones throughout, but happy to take any other questions you have. Thank you.
Thank you, Joey.